Are you ready? Well, thank you all for coming. This is one of the features of IORG month. The Information Organization Research Group is we're proud to have gathered a series of speakers through April. My friend Charles van den Heuvel is our first speaker today. Charles is a senior researcher at a wonderful place. It's called the Virtual Knowledge Studio. It's part of the Royal Academy of the Arts and Sciences in Amsterdam, the Netherlands. And Charles is a bit of an artist and a bit of a historian and a bit of a scientist, and he manages to merge it all together into some magnificent work. He and I were participants in, he's going to tell the whole story, participants in a workshop a couple of years ago, and from that sprang this project about the Idea Collider. And so Charles is now here for several days on some grant funding that we received from the school so that he and I can see whether we can actually build this thing. So with that, Charles, I'll turn it over to you.
Okay, thank you. Okay, thank you very much, Richard, but also for the whole group here for being here and also for inviting me, and also thanks for the grant, I must say, because it allows us also to work together. We started a couple of years ago, but it's also important that you can sustain that, and this sort of grants are very important to meet each other and to be able to work together, to write abstracts together and to publish together, and I'm very pleased that I can stay here for a couple of days for working together with Richard, but also with meeting your group. I'm working basically on Paul Autelet. You saw in your program that you a couple of weeks ago had Thomas Deuza here. He also presented something on Paul Autelet and language. If I understood the theme correctly, I'm mostly working on the visualizations of Paul Autelet. And don't know whether everyone is familiar with Paul Autelet.
Don't look at me like
okay,
that.
well, I will fill you in. Paul Autelet was a son of a lawyer, but with a very big scheme in mind. He wanted to organize all the knowledge of the world. For that he had an institution which was called the Mondaneum that would combine all sort of archives, museums, libraries, but also a network which could send out by radio information to all people in the world. And the idea was also that we, with this knowledge organization which he was having in mind, he tried to improve society. He lost his son actually during the First World War, and he had the idea, and kind of positive view, but also a modernist view, that if you make if you organize society, then you will have a better society, and knowledge organization was instrumental in that. This was really a mission there. His connection, he has written hundreds and hundreds of articles and a couple of important books, but also was making drawings all his life. He has made thousands and thousands of drawings, which are nowadays in the archives of Mons in Belgium, the archives of the Mondaneum. And I'm basically working on those drawings because it's quite interesting to see how a person is trying to get a grip on knowledge by making drawings. And his texts are quite rigid, I must say, but in his drawings you see him struggling, bringing all sorts of ideas together, creating interfaces between knowledge, and that is mainly what interests me in the work of Autelet. Okay, let's start with how Richard and I met. Richard already mentioned it briefly. This was in September 2008 at an event called the Picnic event in Amsterdam, and the idea is that artists and scholars work together to come to a kind of innovation. We also created art together. Here you see a so-called issuescape. Here you see the creative work of Richard and his group. Mine is lost in cyberspace, I don't know why, but this is at least the one Richard has been working on. And it was at the very same day, actually, that the experiment was with the Large Hadron Collider, which you might remember. So I remember in that time it was said that we would all vanish in the black hole. That was that very day. It's possible that it happened, but at least we're not aware of it. But anyway, that's when we start talking. So we were actually discussing our figures with each other, so why it was made in this way. And it had to do with horizons in this view, and we will come back to that. Anyway, Richard and I started talking about deconstructing knowledge, and since it was the day of the collider, we came up with the idea, why don't we use the collider as a metaphor to deconstruct knowledge and to see how this can bring us further to theory development. So it is a metaphor, of course, but still it helps us to get a grip on what happens if you break knowledge down and if you try to bring it together in different ways. Since then, we have had a couple of meetings, but also exchange in other formats. We have been making drawings and sending that up and down, but also in some occasions Richard sent some films, so that allowed me to follow.
Hi Charles, I was thinking about this week and I decided I would make you a little video because I'm just learning how to work with this camera. Sorry to get distracted. I've been reading more of Stephen Hawking, and I've been reading his book called The Universe in a Nutshell. By the way, it's a really great book. When we write a book, I want it to look like this. It's a good example of a combination of familiar graphics to illustrate his complex concepts. So he's talking about space-time, and he says to, for an example, consider drawing a circle on a piece of paper like this and cutting it out. And when you cut it out, you have like a pie, and you've lost a segment of the pie. And then you can pull the ends together and tape them. He says to glue them, but I'm just in a hurry, so I'm going to tape them. What we have here is a cone. Now, why this represents space-time is because we still have this. We still have something that is flat, even though it's also a cone. So it has that dichotomy. It's missing a segment, but the circumference is still the same. It's just missing a chunk. So that's something that happens with time, pieces of time, that space-time that can't be seen. The cone, the tip of the cone is the singularity, or the beginning, and the edge of the cone is a black hole, a point beyond which nothing can be seen. In the center of the cone are these places, and these places are event horizons, in other words, points to which various people can see. And what you could say is that when we were looking at the issuescape from my group, you said out loud, it looked like things colliding at CERN, and we began thinking about the issue collider, and then we began putting together the metaphor to see how far it would stretch. And oddly enough, this piece of kindergarten construction work is reminiscent of an idea that begins at the singularity, and over the course of time, as it stretches toward some infinity, it becomes a work, and the work begins to evolve, and the shape of the structure of the family of instantiation looks a lot like this. And what we realized or recognized at the beginning of our work together was how similar these two things are. And as we've begun to compare pieces of the metaphor, we found more and more and more evidence that the structure of knowledge is similar to
Okay, I just cut it down here. Actually, you can go home now because this was a complete explanation, of course, what I was going about to say. But we came up with the collider idea. What we didn't know by that time was that there were already projects dealing with the collider. So one huge European project, which is called the Large Knowledge Collider, but that's basically to do with the semantic web. And then there's another one which is called Visioneer, which is here called the Knowledge Accelerator. And that comes closer to what we are having in mind, because they are thinking of how they can develop new sort of concepts with this collider, but then specific in their context is in social economical context, which is quite different from what we are having in mind. So we still do not know where it exactly will bring us, but we do already know what we don't want to do. So first of all, we don't want to develop a theory of everything, but try to come to a kind of elementary theory of knowledge. It's not about classification, but rather about the nature and behavior of knowledge. And finally, as I said before, it's not about the semantic web, but more about knowledge structures between concepts, works, instantiations, and documents. So this is more or less where we want to talk about. First of all, we'll talk about Paul Audelais, and specifically about his interest in physics, which is developing, and what implications of that is for his universal decimal classification system. And then Richard will take over by the status questions of the metaphors of universe of knowledge, and then set out the first ideas about the elementary theory of knowledge by the use of the ID collider. So Paul Audelais, already at the end of the 19th century, in 1890, was already thinking about the book, taking the book apart, and he says, okay, what happens is a rearrangement of the content, not along the lines of a special plan of a particular book, but according to the genus and the species appropriate to each element, and this does not make for any loss of substance. So you can take the book apart, but you still will have the components which you need for knowledge. So the more people have been working on the atomist approach of Paul Audelais, Boyd Rayward, the biographer of Paul Audelais, has been working on what is called the monographical principle. The idea is that all the knowledge from different sort of documents, as you can see here, journals, periodicals, laws, brevets, statistical materials, books, all are put in a grinder, and then it is broken down, and then it ends up in a classification system, and then it is disseminated all over the world. Michael Buckland also has been working with this theme, what he calls information as thing. Here you see also in the scheme of Paul Audelais that it says that tout peut être un document, and he shows statues, buildings, discs, everything can be a document, which then will be filtered down in that system. So all sorts of parallels, and this of course is a black hole with an event horizon as explained by Richard in the film. So there's also one big vast of information which develops over time. What they have in common, most interpretations of this atomic approach, is that they are very much interested in matter. So Boyd Rayward, Michael Buckland are all referring of breaking down all knowledge into matter. What we are more interested in is that apart from matter, what does it mean also for visions about energy? Because Audelais is also thinking quite a lot about breaking down information to come to action. I already said that he's trying to create a better society, and in order to do so, you have to organize things, you have to plan things, and that needs energy. So this is the line which you see in the work of the interpretations of Boyd Rayward and Michael Buckland. Text, paintings, images, diagrams, objects, all are taken apart into elements, and these are new expressions and can then reassembled in different sort of formats like books, encyclopedias, museums, didactical material. So they're very much interested in what happens if it breaks down, and then you can recombine it, and what do you get here. But there's another line which you see here, and that's a very often forgotten line, and that is his whole translation of ideas to action. So you have first the perception of reality that leads to certain thoughts about that reality, which then becomes develops into science. Science expresses this in different ways, so this is the common point, and that in the end must lead to action. So that's a far more an energetic sort of flow in the knowledge organization of Audelais. The book, as I said, is not apt to express ideas well. So the documentation, how can you come from a documentation in material forms towards an architecture of ideas? as he said in its actual form, the arbitrary division in lines and pages of the book does not correspond at all with the one of ideas. And he's struggling with getting a grip on the senses. So he is developing what he calls sens perception documents. So these are really sense perception documents. How can you link various sort of notions, not just text and image, but also something that can be heard or felt or tasted or smelled? In what can you translate that into documents? How can you get a grip on that sort of information, what is not material, which is really linked to the senses? So, before I come to the more atomist approach of Otlet himself, I want to explain that it stands in a tradition, an historical tradition. In the 19th century, not just people interested in knowledge organization, but also physicists themselves who are interested in metaphors of atoms. So you have a big debate in the 19th century whether the universe consists of matter or of energy. Some people think that it are particles of matter, but someone like Ostwald thought that the whole universe was made up of gas. So that was a huge conflict. Ostwald, by the way, was working together with Paul Otlet quite a lot. So you have this discussion, and Otlet was aware of this discussion. Boltzmann was the one who really had the idea that it consisted of matter, of particles of matter. And to get a grip on that debate, he came up with the idea of atoombeelden. So these are representations of atoms. These are not real atoms, but these are images of atoms, because he thought I can bring the parts together just by introducing this metaphor. Because for the people who believe in matter, they can say, okay, these are just representations of the particles as they know them, and the people who believe in God, they say, okay, well, this is not real, these are just representations. So he hoped to bring the particles together. That doesn't work out, of course. The scientists did not accepted his view, but at least it was an attempt by means of using a metaphor to convince other parties within physics for his point of view. Otlet is becoming more and more interested in physics, and a lot is going on actually in the place where he's living. He is working and living in Brussels, and in 1911 is the first meeting of the Solvay Conseil de Physique et Chimie, that is the Council of Physics and Chemistry, which was organized by a very rich industrial person, Ernest Solvay. So he invited all the famous people over the world who were thinking about physics and chemistry, people like Madame Curie, Max Planck of the quantum, Einstein, all those people were invited to Brussels. The meeting still does exist. Every 7 years there are meetings, and people, most of them have been organized in Brussels, and yeah, it's of course invitation only. Otlet was not present at the meeting of 1911, but Robert Goldsmith was, and Otlet has written 2 books together with Goldsmith, so there was a close relationship at least to the person who were involved in physics. And then in this is another meeting. This is the meeting of 1927. This is the famous meeting where the controversy between Einstein and Bohr came to the foreground. Here you see Einstein sitting, but also this guy you see here is de Donder, and de Donder is a friend of Otlet. So he had very close links, although he couldn't participate himself. He had at least very close links to people who made part of those meetings, and he was following it closely. You also see that in pieces in the archive of the Mondenay. So these are notes of Paul Otlet in which he describes all the names of people since 1807, what they are thinking about atoms. So he mentions Dalton, he mentions Faraday, Van het Hoff, Ostwald, and so on and so on. So he mentions all sorts of people, what their visions are on atoms. And in another document here he says that all the sciences are related to physics. So astronomy, chemistry, biology, geometry, all is related to physics in his view. And then here in line B he says that in the end physics will come to one rule. So it's very important that you can capture everything in one basic rule. And that's also what he tries to do with the world, actually. He just makes a formula of the world, so that makes it easy. So you have the world, consists of objects and subjects, and of course we have something which we do not know, inconnu, a mystère. But you also put that in your classification. Everything, the whole world is classified. He translated that in this formula. These are just the first characters of the French words. So this is quite a semantic sort of formula. That is of course problematic, so from that point he moves towards a numerical notation system so that it's able, so that he can avoid those translation systems. And as I said before, your whole idea is actually to make a formula to come to a better society, so this formula enables him to get a grip on the complexity of society. That's his view. As long as we can capture it in one big formula, then we don't have a problem anymore. So he is dealing, how can I get a best representation of the world? He's doing it in all different sort of ways, in globes and in cubes. So here, for example, le moi, the self, is in the middle, and then around of this is your knowledge universe, which is ordered by time, for example, which is the yellow line, or by space. These are all those expressions of languages and that sort of thing. So everything is ordered around le moi, or the self, in the middle. He's also trying to do it in other sort of representations, which actually anticipate quite modern sort of interfaces with knowledge, I believe, because he is thinking already of a moving interface. So he's talking about a knowledge cube, in which number 1 refers to the domains of knowledge, 2 to the sectors of knowledge, where it is used, like public knowledge, or the knowledge in associations of personal knowledge. And the third side is the instrumentation you need to organize society. This is moving along 3 axes, in which 4 is the detail of information where you go into. That can be local knowledge or regional knowledge or whatever. And then 5 and 6 are standing for space and for time. So you have this cube which is moving along time-space axis and the degree of detail of information. Of course, he wanted to integrate everything again, because he likes integration, he likes synthesis, as he calls it. So he's struggling of bringing all these different sort of representations together, which is quite problematic, because if you have a circle, you have a completely different sort of view of the world than when you have, for example, a cube. In the cube, you can't see the other faces of the cube, and he was moving it along 3 axes, but we still do not know what was on the other side of the cube. So if you have the rings, you have, for example, 9 classes in this figure, but if you have the cube, then you have only 3 classes, and you have 3 lines, which gives you 6 instead of 9. So that's all problematic, and he's still struggling. How can I bring all these different sort of representations together? That's also what he tries to do with classification. He says the reason that is that while one can currently refer from one classification to another, in the future ways will be found to merge classifications. Refondu is the French word he's using, in order to create a single instrument that can be applied both to the sciences and to its documentation. So he's ordering information, but it is very important that in the end all those classifications of the world in the end come together, so that you have one single classification which can be held in the sciences and in documentation. And then we have a problem, because he does a lot of study of the physics, but if you read the relativity theory of Einstein, then he becomes aware that it doesn't work in that way. So first of all, the laws applicable to macro-physical objects are not applicable to micro-physical objects. So you just cannot scale up. This is actually a Voronoi diagram that says that the dots on the wings of a butterfly cannot be scaled up to a larger size. But a lot of Voronoi diagrams which actually explaining the impossibility to scale up things. Another problem is the notion that time and space and matter and energy cannot be separated anymore. So this is of course quite a problem, because if you first have very nice defined classes which I've shown before for time and for space, but then time and space are linked, and matter and energy are linked, how do you keep them apart in a classification system? So everything is merging there, and that's quite problematic for his view. Luckily, he thinks that he has a solution, and it is mathematics. Mathematics can bypass all those sort of problems, and that's also why the decimal classification system is so important, because you can just hop from one specific code to another one. But of course, very often you are not solving the problem, you are very often just bypassing the problem. What he is saying is mathematics is not only has become an instrument to realize a higher level of abstraction, it becomes thought, la pensée itself. Mathematics is not just a translator of concepts anymore within that system, but it becomes a producer of concepts. So here are very high expectations of what the sciences are able to do. This belief in physical laws is still present. You see it here, for example, in the work of Tim Berners-Lee, where he says, one of the beautiful things about physics is its ongoing quests to find simple rules that describe the behavior of very small objects. Once found, these rules can often be scaled up, so he believes that it is possible to scale it up, to describe the behavior, also important, the behavior of monumental systems in the real world. I think that I leave it here, because we now get to the next stage where Richard will explain what the status questionis is of the metaphors of universe of knowledge, and what our thought experiment will mean for the development of a new elementary theory of knowledge.
Thank you, Charles. When we began talking, it really did begin, as he showed you, with that issue scape. And he said, that looks like a collision in the collider. And I said, well, it actually looks to me like an event horizon. And we started talking about quantum theory, and we began making a chart of the basic elements of quantum theory. And as we did that, we sort of recognized that pieces of it were familiar to us from somewhere. And we would start making drawings, and Charles would say, oh, Utley has a drawing like that. And I made the paper cutouts, and he says, oh, Utley made paper cutouts. And so we were going in two directions at once. We were trying to fill in our chart with bits of what is known empirically in knowledge organization about the theory of knowledge, and documents, and the instantiation of knowledge. But we were also working in the other, maybe on another dimension, with the for me, shocking discovery that this was all discovered a century ago and seems to have vanished. So we're, in a sense, reclaiming what Utley discovered. Now, what you have on this slide is the beginning of our conversation, which is metaphors of the universe of knowledge. And I'm not going to narrate it directly, but what I'm going to do is point to Patrick Wilson's Two Kinds of Power from 1968 at one end, and Elaine Svenonius's Intellectual Foundations of Information Organization at the other end. Now, Patrick Wilson wrote his Two Kinds of Power at Berkeley in the 1960s. Those of you of my generation will remember that that was the age of Aquarius. It was a time of, it was after the Second World War, it was during the Vietnam War, it was a time of massive shift in the social fabric of at least Western societies. And we were very hopeful. We were also very put upon by our elders, but we were very hopeful that we would create a better future. And so I think that whole concept infuses Wilson's book. Yes, he lays out the elements of what he called bibliographic control. He calls it an essay on bibliographical control. But he also infuses it with hope that empirical research can inform a better future. And now you have, 40 years later, Elaine Svenonius on the verge of a new millennium. She wrote her book at the same time I was writing The Nature of a Work, and they were both written in 1998 and published in 2001. So we were both writing at that point, at not just at the end of the millennium, but at the end of nearly 4 decades of empirical research fueled by the theories that Wilson put forward in Two Kinds of Power. The idea that there is a universe of recorded knowledge, that that universe is populated by documents that contain texts. The texts act like celestial bodies. The celestial bodies have physical relationships between them that we can map, that we can quantify, that we can trace over time. So some of that gets written into Svenonius's book in 2001, and by 2001 she has begun to describe Wilson's concepts of the domains of exploitative power and descriptive power. She's describing them as languages, and she develops a set theoretic. What I didn't like about her book when it was published, and now just as I'm talking dawns on me is its real promise, is that she sets out this whole groundwork and then the book just ends. She never follows through with it. Well, of course, it is, much as Wilson's book was, a challenge for the next generation of scholars to fill in the details. All right, so what happened over these 3 decades? A lot of empirical research happened, and 2 important studies, only one of which is mentioned here, are studies by Barbara Tillett and Richard Smeralia. Barbara Tillett studied bibliographic relationships by taking a sample of all the MARC records in the Library of Congress, and it was really an impressive feat of documenting bibliographic relationships, but it was an even more impressive feat of documenting the empirical reality of a collection of millions of bibliographic entities. And hidden in the tables and the statistics in the back of her dissertation are just thousands of facts that demonstrate these concepts that the universe actually is populated by recorded knowledge that is communicated through texts. The texts are the embodiment of works which are abstract at some level, but then instantiate over time. Now, of course, my research into works demonstrated more of the details of how works work. They are ideas which have semantic expressions, and both the ideas and the semantics they instantiate over time, by which I mean they take different forms at different points in time. They can mutate, which is to say change dramatically, or they can simply derive by being reissued. Both sorts of things happen simultaneously. And then we have this landmark book by a collection of essays put together by Rebecca Green and Carol Bean called Relationships in the Universe of Knowledge. And that's how it gets on this slide, is that we have a universe in which knowledge resides, that knowledge is contained in quantifiable entities, and that the entities are controlled by the relationships among them. Now, what is it that makes up a universe of knowledge? Knowledge organization is a field, the formal group, the International Society for Knowledge Organization, is a field made up of scholars who base their work on what they call concept theoretic. That is the notion that what we really care about are concepts. But there's another slide about this later, and I keep getting mixed up with the placement. But the fact is we don't know what a concept is. Now, Miri Hjorlund says he does now, in fact, know what a concept is. And this is what he says it is. This was just in February in Rome, however. So he says the concepts are dynamically constructed and collectively negotiated meanings. Now, dynamically constructed means that they exist in space-time on a continuum. Collectively negotiated means that the energy brought to bear on them is not simply intellectual, it's also social energy. So concepts, we say then, are like particles. So our universe has in it concepts. They'll go on. But, as we like to point out, we're not sure we believe Barrier's definition, and we don't know exactly what the concepts really are. Other people have different ideas. So we asked this question in our paper at the conference in Rome: how can it be that the order of that which is known is dependent upon the behavior of an unexplained phenomenon. So that really is our challenge, to explain the phenomenon in empirical terms. Empiricists are rare in knowledge organization. I'm the one. Oh, there might be a couple more. But primarily KO is a rational enterprise, and I keep insisting we need to know the facts. Just the facts, man. All right, so Charles told you at the beginning that what we care about is an elementary theory. We want to formulate a theory that says that things in the physical universe are made up of matter and energy. Energy is the force that binds matter. Information is the accretion of energy. And entropy is disorder that precludes information. So in our metaphor, we draw a parallel then with ideas, or raw ideation, which are the matter of knowledge, and intellectual force, which is the energy that binds ideas. The process of ideation yields information and entropy as exact parallels to the physical world. Individual ideas are expressed with concepts which can be seen as the particles of ideational matter. Got that? There's going to be a test.
Open book, I hope.
Okay, ideas are made up of concepts. Concepts are made up of smaller particles, signs, and the expressions that signify them. These can be grouped into taxons. Taxons exist in taxonomic waves. Taxonomic waves constitute measurable canons. Whoops, Charles. What did I do?
Oh, hey, sorry about that. Apparently I changed the location of it.
Is he here?
It's in this folder. Sorry about that. We'll make it easy with a minute.
Okay. Wave theory tells us that physical entities exist in space-time in a manner similar to the action of waves. The wave rises and falls as it moves through space-time. In the wave, washing on shore and getting there before the surfer, is the surfer was there to make you laugh. Is a group of taxons. The taxons become expressions. Expressions become ideas. Ideas become works. Works become canons. All of those things, from canon to taxon, instantiate across space-time. The content of the wave is a canon in which works instantiate and reside through space and time.
I'm overwhelmed with human.
Got it? I got it?
Okay.
All right. Space-time, then, is analogous to instantiation. Event horizons are points in space-time from which we can view the physical universe. In other words, every point at which we stop and cast our net empirically into the bibliographical universe and count what exists is like an event horizon. Every time we do that, we will get a different measure of the quantification of knowledge because of the concept of energy crossing space and time. Spin is the description of the motion of particles in space-time. Spin is analogous to the semiotic action that we know from Charles Sanders Peirce of the movement of representation to interpretant to object through space and time. So what we want you to do is imagine that this is the collision of an idea falling apart in our collider. The matter and energy separate. They are held together by the intellectual force brought to bear on them. The spin is taking place constantly, and this is the action of semiosis, as every expression moves from its utterance to, from its origin in the mind to its utterance to its perception. And that brings us to perception, which is the point at which phenomenology also comes to bear on the intellectual force in space-time. So, what are we going to do? We hope to build an idea collider. We're beginning by continuing to map out these pieces of elementary theory. We want to study epistemology, semiotic theory, phenomenology, postmodernism, and their intersection, which we perceive to take place in this theory of the motion of knowledge. Postmodernism allows us to embrace many explanations at once. Semiotic theory tells us how spin creates fluidity in the recognition of knowledge. Phenomenology tells us the manner in which different phenomena encountered at different points in the continuum seem to have different reflective definitions. We want to create a metaphorical device that allows individual concepts to be spun about until their several parts are broken into elements. A simple way to put that is we want to build a machine in which we deconstruct knowledge into its parts and then relink the parts according to their structure and function, not their semantics, because we believe that the structural relationships will bring new knowledge, new undiscovered knowledge that exists, but we can't find it because we can't see it. We want to group it together in this way. And so the question is, will it be possible to operationalize these research questions and create an explosion? Thank you. Questions?
Yeah, two questions. The first question, you have an idea to break the knowledge down into atoms and rearrange it again. But I was curious about what makes the atom the minimal unit. What's that looks like? Can you visualize that a little bit so that I can see what makes the atom? The second question is about you mentioned the idea is made from the concepts, and the concept is made from the science, the expressions. I can understand the idea makes are both concept because they are both like intellectual in the concept space or in semantic space. But because I thought the science are used to represent the concept, which is in the symbol space, which is tangible. So when you say the science, the concept is made up of science instead of is represented by the science. I just have this two questions.
Just those simple ones.
Yeah.
All right. The atom is. You can sit down. The atom is an entity in physics that is the parallel of the concept in our theory. All right. So we just as atoms can be broken down, so can concepts be broken down. There are subatomic particles, so there are subconceptual particles. We don't yet know entirely what they are. I believe that signs are metaphorical, that signs can exist as physical entities, and signs can exist as conceptual entities, and signs can exist as mere synaptic energy in the brain, and everywhere in between. So what we learned from the study of semiotic theory is that dynamic motion of the spin from representative to object, which is constant. And as I talk, you hear my voice, but what you hear isn't what I've said, because you've operated on the sign that you're perceiving and changed it. Right? So what we want to do is break knowledge down into its components as best we can, but we don't know how we're going to do that yet.
Because what they have been thinking of is, when we say audio information, I'm just thinking like that's divided two space, like the semantic space and the symbol space. We use symbol to represent the semantic. So I think if we know the relationship between the concepts, that's knowledge. You know the two concepts have some relationship. The other thing is, if you know that a symbol represents a certain kind of concept, that's knowledge too. Like you know a cat is a cat, or you know a cat is an animal. It's two kind of different knowledge. I mean, you know the symbol cat refers to the cat.
That's entirely the problem with semantics.
Yeah.
That's really my point here. Is that semantics aren't useful in the way people hope they will be. That what we need to care more about is the structure of knowledge than its external so-called meaning, because the meaning is diffuse. So I'm not disagreeing with you.
I just
Charles, did
kind
you?
of want.
I was didn't cost me too much time. I was looking for the table we made.
The table,
Because,
yeah.
I will still try it, but what we did also as an experiment is to see, okay, where are bosons standing for? What are the different particles within the atom, and what does that mean in relation to the way we divide up knowledge? And we made an attempt, but I'm still searching for it. We made a kind of matrix in which we brought them together. And I hoped while Richard was talking that I could find it in the meantime. That takes more time than expected.
Yes.
So, I mean, historically, the idea of an atom was that it was indivisible. I mean, that's the essence of an atom. Now, physicists discovered that atoms were in fact divisible, but by then it was too late to rename them. But, I mean, atoms, for most practical purposes under normal circumstances, are indivisible. So, in natural science, the whole appeal of the idea of the atom was the indivisibility, and that gives you, no one could see atoms or directly observe them for a long time, but you knew that it was down there somewhere. And that gives you this advantage that when you've got an atom, you know what it is. And it seems that with concepts, there's no, you can just keep breaking them up forever or recombining them. You can't really see them, but there's no fundamental inherent granularity of concept. And so when you're taking this metaphor forward, and I thought the historical part was very interesting, because this is the period at which people are realizing that atoms in fact are not what we always thought they were, and that they can be divided and recombined, and you've got these subatomic particles, and you see your historical actors kind of trying to deal with this, and the threat it poses to this assumption that there is in fact the universe can be divided nicely up into these inherent units, and that the different axes are separate and so on. But now, so I guess my question from this would be, now you know that atoms aren't atoms, what is this atomic metaphor getting you? Because your version of the metaphor is built into it, that in fact you can make them small, you can make them bigger, they're made of things, and you're getting all this complexity. But are you losing the basic benefit of the atomic metaphor, which is the idea that there's an inherent granular unit of something?
Can I take it? The whole idea of the collider experiment in this metaphor is, of course, that those particles are clashed together, collided together, to get a better understanding of the origin of the universe. So it is not just about understanding the particles, it is also a kind of learning about what always has been there since the beginning. We saw in the theory of Hurland, we saw that it was all about the kind of epistemological approach that people create knowledge. But what this experiment could explain perhaps is to which extent this is ontological. Is it about the matter which always has been there, or at least, and something which we co-create as people when we are perceiving knowledge. So it is not just about to see at this moment in time what is the smallest particle of knowledge. It is also the whole history which is actually in those particles. And since it is not separable anymore, because we in the theory of in the gravitational theory, matter and energy cannot be separate anymore. It has to be broken down again in further part to get a better understanding of what is ontological, what is epistemological, for example. Do you agree with that? Because I make it up on the fly. So.
Yeah, I don't have much to add. As you were posing your question, I kept thinking, but classification is based on the idea that concepts are the smallest particles and that they're recognizable. And so I think in a sense we're trying to explode that notion as well. I mean, we were saying, well, as you said, the atom doesn't give you indivisibility, and neither does the concept.
What makes the concept recognizable?
I would say we don't know yet.
But wait, from your last answer, do we not know yet, or can we in fact never know?
That I'm not certain about.
If you were a constructivist, you would say that it's constructed by, well, psychological constructivism in people's heads, and social constructivism in terms of the negotiations of meaning between people.
Yeah, but I think that this experiment goes beyond that, in the sense that the question is also whether there's information in the universe at the beginning of the universe or not. So is it something what we just as people have added, or is there also something there? And I don't mean necessarily in a religious sense, but I mean that's also what one tried to understand from the collision, whether we can find something about the origin of the universe. So then that means that the basic particle would consist of something which was in the kind of continuum there, and something what we perceive either on a psychological level or a sociological level, what we put to it. So it would be both in that case. So I don't believe that it's just a social construct or just a psychological construct.
If you strip out perception, that entity is there, regardless of how we perceive it differently.
But what you're arguing is that the concept can exist without the perception of the concept.
No, we're hoping that we can strip away the perception to understand the concept at its basis.
I think you need a word, though, don't you? Because concept assumes a knower.
On the other hand, I must say that if you go back to the collider again, first you had atoms, then you had smaller parts. In all those cases we have put a new label, a new name to the tiniest elements. So yes, it is possible that we're going to individuate something which we didn't know, which is next to the things which we have created ourselves. And then it has to be labeled to talk about it. But we do not know yet. So also in this experiment of the Large Hadron Collider, which has just been run recently again, the idea is that they still hope to find missing elements. They expect that they are there, but they don't know it. Once they find them, they have to label them, and I think that would be the same analogy.
Yeah.
But of course we don't have a choice as human beings other than just to label that, or to, if we recognize it, then we shall label it one way or another.
But we label based on the sense of relation a priori. I mean, what you're saying is that you want to drill down to the basic element,
Yeah.
but you still have to progress through a set of labeled perceptions. Because you can't perceive it if you take off the labels, right?
You can still perceive, but it's just unlabeled concept, and then you name it. You might be there are some concept is unlabeled, and then, but you still perceive the concept. Then you want to name it. Then you give a name. Let's say a bird is a bird.
Problem without name.
The idea is, of course, we know that a lot of elements in the atomist model are component of the other. But if they fall apart, they can fall apart in a different way than we expected. Then you will have some granularity in between, which we do not know what it is, and that will be labeled then in a different way than just the two components that we did know. So what you know, for example, say, okay, we take matter and energy apart and assume that something falls out there, then that has to be given a new name. So yeah, I think that you can't exclude perception, because at the moment that you break it down, you have a perception of the thing, with the phenomenon which you are analyzing. But still can be different from the format that you had before the collision.
Okay.
And also different from the formats of which it was composed beforehand. At least our understanding of that.
But I think that's the question that we have. I think, are you looking for a degree of purity in the terms of concepts? How is the purity possible in a world that is based on perception?
Well, the question is whether everything is epistemology or not, and or whether there is also something ontological, and whether that has a history or not.
Okay, I'll stop.
I've got two ideas from that. I mean, the first one is, like, if we don't know a concept when we see one, it's not really a surprise that we can break it down into smaller pieces, right? Or that, we don't know if we're colliding two different concepts together or taking one of them apart, or, so the utility of the metaphor I'm not entirely seeing. But the other thing is that I think what I think would be interesting is to follow forward with the kind of historical thing and tie it more into philosophy, because I know there's a lot of philosophy of knowledge out there, and what I know is I find it very hard to read, and I went in another direction. But I would be inclined to tie this idea of atomic units of knowledge very much to positivist philosophy of science, and with the way people thought about ideas and concepts, 1900, early 20th century, and clearly kind of parallel with developments in physics and people I know who've worked on the kind of metaphorical connection things. You've got Wittgenstein, logical positivism, sociology of scientific knowledge, a whole bunch of kind of other fields, which really, I would say, inherently and hopelessly undermine the idea of the purity of knowledge as something that can be isolated, of atomic units of knowledge that can be value-free and combined, and so on. So, following through the history, that would be kind of interesting. But, I don't think you can take postmodernism and tacit knowledge and the ideas of knowledge as being something that's embedded in structure, it's cognitive or has to do with the physical composition of our brains or whatever, and work those as kind of little factors in this kind of metaphor. I think once you allow those into it, it just destroys the whole idea. And that's why nobody has, that's why the idea of atomic units of knowledge that can be organized like that is something that we need to stop talking about, in my view, because it's something that's bound in with this whole mindset that made sense a century ago, and fundamentally doesn't today.
Well, I certainly find it a good argument to do this from a historical perspective and to look at positivism and also to neo-positivism thought. And actually, you can also see in the work of Adler himself that he is making a kind of transition. What he first in 1890 really was in search of basic facts, and later is more bringing in metaphysics for example. But still, if you deconstruct it, then you need and you're developing a theory, then you also postmodernism and the other disciplines which have been mentioned make part of that history as well. So you are looking at what you are having, how you can bring that together again, and it's not clear yet which approach can be brought together to give sense to the things which we are finding. And I think that's why we came up with a kind of mixture of approaches, of recent approaches, to give an explanation for that, what can be a framework to give sense to the things we are looking at the moment. But I agree with you that it can't be separated from a more philosophical approach of knowledge. I don't know whether you want to add to that, Richard.
No, we're open to what we discovered.
It's a thought experiment, and we need to see how far we get. I mean, it's.
I think we're going in several directions at once, and the historical is definitely always a component of what we're doing. And I breezed past phenomenology there, but it's actually also a large component. A question that I have in the back of my mind is why did all of these? Well, you just maybe pointed me toward an answer. Why did all of these theories that emerged about the turn of the 20th century turn out to have meaning now? I mean, Peirce died broke in a little town in northern Pennsylvania. If he had a penny for everyone who's quoted him in the last 5 years, he'd have been a rich man. What about phenomenology? That's a dead theory as well, but it's suddenly finding purchase in the structure of knowledge. So that's a historical question of interest as well. There are lots of questions here. The inseparability of the four components Charles showed is very similar to your idea that classification can't be mutually exclusive.
The other thing that I was thinking of is the whole idea of analogic knowledge is one that I think is worth exploring. We were reading a book by Maureen Code, who's a feminist philosopher out of Toronto, I think, called Ecological Thinking. Yeah. And she talks a lot about the value of using metaphor or analogy as a different way than the classic logical path to reason, or path to knowledge.
My question was sort of asked by these two quicker than I could get to it.
Yeehaw.
Well,
So,
thank you very much. Good note. You want to announce